I'm not quite ready yet. Let me first quickly open a bottle of water for me. Also forget to cut a little flower for my wife because she helped me a lot with this presentation. I need to prepare some food because my daughter gets home later. There's lots of little tools that I need here. Wouldn't it be good if I don't depend on all these different tools, right? It would be quite cool to only depend on one tool. So today, we're gonna actually start talking about this one tool, Swiss Army knife. But actually, I still kind of depend on the Swiss Army knife manufacturer. So why don't we become Swiss Army knife manufacturers? This is what I want to talk about today. We've got an hour now, and we're going to dive into some simple tools, simple helpers, but also more advanced stuff. But before we begin, my name is Ben. I've been doing simulation work for 15, 16 years now. I just had an anniversary today, actually, for being a freelancer for the last 7 years. Before that, I did some McKinsey consulting work and Decision Lab simulation work. So a lot of stuff. And I still think AnyLogic is by far the best simulation tool out there, especially for people who need to solve lots of different problems with lots of different little tools. Because AnyLogic allows you to create your own tools to help along, but also has lots of built-in tools that people typically don't even know about. So we'll explore some of those as well. What we're planning to do is we want to become the toolmaker today. So we first think a little bit about what's this all about? Why can I not use some existing code out there or just start from scratch every time? But then, as usual with these workshops, I try to have something for absolutely everybody's skill level-wise. So we'll start with some very simple kit knife kind of little tools to help you along. For the absolute beginners, even if you just start out today, you can start with these tips. We will then do some more advanced stuff for people with about 6 months, couple of months of experience, up to a few years of experience. But I also always try to go absolutely haywire for the super advanced people. We already heard today a little bit about parallel models and unit testing and stuff like that. And we'll pick up on some of those themes as well. So let's start digging in. Why should we even think about this stuff? Now, I love a good rabbit hole in the internet, just like everybody else. One really fun little rabbit hole to explore is the subreddit DIY. So do it yourself, but why? I have lots of little do-it-yourself projects that just make you think, why would you do that? So let's quickly discuss why we as AnyLogic modelers should do DIY. And after that, we'll talk about the advantages of doing this kind of stuff, but we'll also cover a little bit of the disadvantages. There are some. Nothing is ever black or white, so we'll go into those as well. This is always a trade-off of when you do stuff yourself versus using existing stuff. So why to DIY or not? To answer this very witty and intelligent question, and before we answer that, let me just clarify this. I'm not saying you should do everything by yourself from scratch every time. That's absolutely not the message of this workshop. You should not reinvent the wheel. If there's something out there, and we'll cover this in more detail, then you do use that under certain circumstances, but you need to be aware of the advantages and disadvantages. What we are talking about today is the little helpers in your little niche. I mean, we are in the big fat IT world, in a subgroup of model builders, programmers, whatever you want to call it. In that, we are in the AnyLogic world, and in that is your little niche with your problems, your clients. So we are literally just talking about your specific needs, your problems, the little bits and bobs that you keep stumbling across, reuse, and can make your life easier if you reuse that stuff. That is the big disclaimer, not telling you to reinvent the wheel. Okay, with this out of the way, let's talk about some advantages and disadvantages of AnyLogic, of DIY. So obviously, if you do use existing packages or codes, it's typically not tailored to your needs. So if you have a suite like this guy, that's totally tailored to what you need. That's beautiful. And you should absolutely use that. For example, you might have heard about the unit test framework JUnit. It was actually mentioned in a previous talk. People use it. It's great. It's an industry standard Java package that helps you test your code and your model in AnyLogic. It is an absolute beast in terms of capabilities. It has so much stuff. This is just a tiny snapshot of what it can do. Now, the problem with that is, as a simulation modeler, we are in that niche of the niche of the niche. So really what we need is typically just a couple of functions. We don't need the entire package. So sometimes you have this overhead of trying to learn an entire package. Then these packages develop over time. So there is now JUnit 5. Previously, there was JUnit 4. JUnit 5 is radically different in how it's to be implemented with AnyLogic. So all your previous work with JUnit 4 might easily break. Also, if you use a package that only needs a tiny little bit of that package, there's a chance that that piece will be deprecated and won't work in the future. So your packages change over time, and you are kind of dependent on that external change. So it's a little bit like having this Swedish army knife. It's like that's another thing. You need something, and the package out there kind of gives you what you need, but not quite. And then I went to Krakow the other day and I saw this knife hanging on a marketplace. And I had headphones on with a tourist guide in my ears. And he explained to me that this knife is basically hanging there for the last couple of 100 years. The original purpose was to scare off thieves from the marketplace because they chop their hands off. Now this is deprecated and it just hangs there. So similar things happen with software packages. They move on, and what you needed them for is outdated. So, not tailored to your needs, maybe you should DIY. There's another reason, dependency health. So dependencies, if you've ever done any kind of coding with external packages, it is very troublesome because, again, these packages evolve. So you may remember the log4j incident. It's been in the news a couple of years ago. Log4j is another Java framework that is really good for logging stuff. So it just kind of prints out what's happening in your code. People use it for all sorts of applications, not just AnyLogic, Java-wide, it's everywhere. Until this one security IT guy at Alibaba figured out, there is actually, if you're clever, you can use this log4j to actually take control of other people's machines and move them to kind of bad websites and take control of their machines. It was a huge outcry. And the real problem was not log4j because that security problem had been fixed before. It was old versions of log4j. People did not update their log4j, although there have been new releases over time. So they basically found themselves in this situation. This is a piece of the Berlin Wall. And it sits here in Berlin. I literally found it the other day going to a museum, and there's an ATM in the middle. The ATM works. I'm not sure if this is art, if this is Berlin. I'm really not sure. But this is what happens if you don't update your packages. You have a nice, shiny simulation model or other tool in the middle that is surrounded by crumbling old packages that just you don't update because it breaks your model, or you don't have the time, the resources, or the package is just not supporting what you need anymore, and you run into trouble the longer you wait. My wife also works in IT, and every other day, basically, she says, oh, we had another dependency scare with hundreds of dependencies breaking, and they needed to be fixed and stuff. So dependencies can put a lot of strain. Another example, I recently de-Googled, so no more Gmail, no more Google Photos. I'm kind of have my own little server here on my desk now. And there is open source software. For example, there's a software called Image, which is really good for hosting your own Google Photos. It's amazing. But it's open source, so I'm relying on other people making sure this is good software, secure, updated, and all that kind of stuff. And that's always the case with external work. So you need to be aware of that. You have the dependency trouble. Last but not least, you also lose your intellectual property. If you have a new model and there is a key functionality that you use an external package for and it works, that's cool, that's great. But as soon as somebody else needs to take over the model, or you spend some time on something else, then get back to it, you forget about that package, how it worked, your research, that kind of stuff. Essentially, people don't trust it anymore. And what also happens is that you can't really document that package, right? Either it comes with good documentation or not, but you can't really change the documentation. You can only document your own model and how you use the package. So you have that implicit loss of IP, whereas if you build it yourself, you own the IP, it's yours. So be aware of that as well. It's a little like Chinese whispers with this loss of IP. Somebody just uses the model and then somebody else, and at some point, nobody knows really what this was all about. Now, again, this is not to say you should never use external packages. This is just the kind of reasons for using DIY approach. Let's look into some advantages. And yeah, I'm sorry, I always have to put a little picture of me as a pilot there because it's life to even becoming a pilot. So much fun. I remember trying to justify this to myself and my wife by saying, look, we're going to be so much faster if we want to go places. This will be so much convenient, so much more convenient. We'll be fast, fast, fast. So cool. Of course, we weren't. As soon as I got the license, I realized that there is even a saying in the community of pilots flying these little things. And that is, if you want to get somewhere fast, you better make sure you have a lot of time. Because you don't want to be pressured by bad weather or some malfunction or something and still needing to go. So if you want to go somewhere fast, you need to have the time. Similar thing when it comes to a DIY approach. We heard it two talks previously, I think. Adding your own unit tests or stuff like that does slow the development, but over time you actually get faster. And this is also true with developing your own little helper tools. Of course, upfront, it's a little bit of investment, but you get better and faster over time. Also, another advantage, you can build your little tools exactly at your skill level. So here's my daughter building a traffic simulation at her skill level a couple of years ago, admittedly. And if I would teach her a little bit of AnyLogic now, this would be her traffic model now. So you can grow with your Swiss Army knife and get more and more advanced over time. And we implement that into old models or just apply it to new models. Depends on how you set it up. You have no security issues, hopefully, and no trust issues. It's yours or your company's. Alrighty, but also a tiny little bit of disadvantages there. Let's have a look. Obviously, to be absolutely fair, you may find yourself reinventing the wheel. You don't want that. So before you decide if you're going to develop your own little helper here or not, have a look if there is something out there and if you need it. For example, a couple of years ago, I developed this workshop where you learn how to create an agent-based network in AnyLogic, where each path and node is an agent and you have full control over pathfinding. It's all online, you can build it yourself. But for this, I did use an external package for the pathfinding, JGraphT it was called. Because pathfinding is solved, I don't need to reinvent pathfinding and code it up. It's all there. So of course, I use a package for that, and it's well documented and it's solid. I did a fair bit of research upfront which package to use. So you have to do that, obviously. Another situation is that you need to build a model with some capability and you're just not good enough to even consider coding that yourself. So for example, I built this different workshop about reinforcement learning where you learn how to implement a reinforcement learning algorithm into AnyLogic and make it learn stuff. Now, the algorithm I coded from scratch because I wanted to learn how reinforcement modeling works, at the core, but the algorithm I implemented was very simplified and wouldn't hold against like real industrial applications. For those, I would still use a package because it would be absolute rocket science to recode this, and it's all out there anyway. So let's be fair. A DIY approach absolutely has has its place. This is what we want to talk about, but also using packages is absolutely critical. Good, enough of that. Let's actually get practical. Let's take our little butter knife and do some very first knifing, some very first cutting. Now, you may not have heard, well, if it's your first day in AnyLogic today, you may not have heard about it. Otherwise, I very much hope you've heard about it. The most powerful tool in AnyLogic for building good models is a little code line, and it's called traceline. Now, what this does is, let's have a look at it. If you write this line of code, traceline, and then some string, all it's doing is if you click that button where the code line is, it prints that string into the console. It's very trivial. You can do this very, very easily. Now, I talked to a very, very, very experienced AnyLogic modeler, probably the most experienced AnyLogic modeler there is. Anyway, he told me that he's never used the debugger that AnyLogic comes with. He always uses tracelining to debug stuff, which is fair and is fine. I would strongly recommend you also use the debugger for certain problems, but me, myself, I also find myself using traceline every day. So don't skip on traceline because there's some useful stuff you can do with it. Let's have a look at this little model here, where I have a process flow with a couple of blocks. And what I can do is I can use the traceline and I can make it write what an agent did when it left this source block. On an exit at some model time, some specific agent left the source. I can do this in the queue block with all these different action items. I can do it in the delay block. And if I run the model, I get this very nice timeline of the agent. So I can read up on what my agent did, which is very, very powerful for debugging or understanding what's going on in the model. What the hell is this agent actually doing? So learn to use the traceline if you have it. There are a couple of little tricks with traceline. For example, you can give it one more argument, the color, and you can also apply some formatting. So in this code here, I'm giving it the color red. If I click that button, it writes the traceline in red, and it also formats the strings. So I'm giving it lots of strings here at the end, and one format string as the second argument, and I'm kind of reorganizing how those strings should look, how they should be formatted. These are standard Java formatters that any LLM these days can help you with, make your strings look nice, make them group by something, stuff like that. Just have a go at that and experiment a little bit. But what you can already see here is me starting to come up with a framework for my tracelines, organizing that by category. Is it an error? Is something really, really bad? Is it a warning? Kind of weird. You should look at it. Or maybe just an info message. You should be aware of it, but it's nothing to worry about. This kind of stuff you can already do. Then you can expand on that. AnyLogic actually provides more than traceline. There's a warning function that works very, very similar. You just give it a string, and we'll see in a second how this differs from traceline. There's another one called error with a string, and this one will actually throw an error. We'll see in a second what that looks like. So when you click the warning traceline, it just formats it in a predefined way. If you click the error one, you get this very, very frightening error, especially for beginners. They see these things and they run away screaming, which I don't blame them for. But this time, it's your little error. You can write a very friendly error message and basically say, hey, Ben, calm down. Everything's good. Everything's good. Just there is this serious logical issue here. You better check out button 1. And obviously, it's up to you to make this a really good error message. What happened? Where did it happen? And what do you suggest should be done about it? Alrighty, so lots of tracelining stuff. Let's talk about the next thing. This is now the point in the talk where I say, this is the one thing you take away. If you don't take away anything from this talk, this one thing, please. If you know in your model somewhere something should never happen, you write a sanity check about it. I'll be calm for a moment because I want you to remember this. If there is something that you know should never happen, you write a sanity check. Now, this is so important that I prepared a physical prop, which basically says the same thing. If you know that something should not happen in your model somewhere, you write a sanity check. So let's talk about what I mean by that. This is very, very important. Let's look at this little delay block here. I define the delay time, the time that you spend in that block with a little function. Now, what do I know at this point in the model should never happen to a delay block duration? It should never be negative. You can spend 0 time in a delay block and any positive time, but it cannot ever be negative. Now I know that. So what do? I write a sanity check. So in this function get duration, what I actually do is I compute the duration, whatever, that can be some complex calculation, can come from anywhere in the model, it doesn't matter, but it may be that this duration is negative. And in such a way, I now traceline a warning message to myself. I say what happened, where did it happen, and what am I doing about it? In this case, I'm doing a clever little thing and I actually replace the duration variable with 0. So this function will never return any negative value. It will return a positive one, but if it's negative, I have a nice traceline warning and a 0 duration. Let's have a look at another sanity check example. Here I have a flowchart where I push person agents through, and at some split by age select output, I want to split them by their age. So the old ones go to this one, the young ones go to the lower bottom. So I call the agent.getAge function, which is in the person. And what do I know about age of persons in my model? Well, age should never be negative, but it should also not be too big, right? Too old. That would also indicate something weird. And because I know this, I write my little sanity check. In this case, this getAge function really just returns a parameter, but again, it can be something else. I just, before I return what I want to return, I check that it's not negative and not above 99. But also notice here, I'm not actually changing that. This time I'm not replacing it. And this is your decision. This is up to you. It's also your decision if you throw an error with a sanity check. What I'm saying is litter your models with sanity checks. This is really, really useful. Another last example, agent is defined by a state chart, on shift and off shift, but also by a location. Typically, the agent is lazy and at home. But what do I know if my agent starts the on shift? What's the one thing about this model that I know should never happen? The agent should not be at home. If I know this, I write a sanity check. So whenever I start going into the on shift, I write a sanity check. And if this is still at home, I throw a message. Now, my models for my clients are littered with these things everywhere. I literally don't think about anything else when I code or when I put in blocks. It's what should never happen here. Let me put in a sanity check. When I run models, very often I get a lot of text. Some of it is like info, that's harmless, and some of this is warning, I need to check it. Some of them are error messages, that's really bad, needs to be changed. So litter your models with these things. They are cheap. Do not think that your model will be slower because of sanity checks. These days, this is not a problem anymore at all computationally. Sanity check, sanity check, sanity check. Alrighty. Let's do some more cutting. A very simple one this time. Well, let me start with a riddle. What's the second most important skill as a simulation modeler? You might think, well, wait, Ben, did you talk about the most important one? Yes, I did. Last year. So check, the entire workshop last year was about the most important one, which is about asking good questions and becoming Sherlock Holmes. But the second most important one, it's not coding ability. It's not theory. It's not even practical experience. The most important skill, the second most important skill as a simulation modeler is habit, like brushing your teeth. Good habits are a superpower that people don't value enough. So get into good habits like brushing your teeth. For example, we all want well-documented, self-documenting simulation models. Wouldn't that be nice? Everybody wants them, but very few people have the habits to make it happen. So just like a sanity check writing is a habit, making a model self-documenting is also a habit. And here's one way or one habit that you should follow. Whenever I create a new agent type, the very first thing I do is I paste in from an existing agent, I paste in this group of rectangles and texts. So I always have it ready somewhere. I just paste it in. The first time you set it up, you give it a good name. So every element there should have a really good name. This is really just if you ever start using inheritance, you might run into trouble. So give it a good name and you're good to go. And then the second thing is you kind of adjust this for this agent type. Will you have parameters? But the most important thing is you describe briefly, what is this agent for? Why is it here? What should it be used for? And maybe some other important stuff. For example, this is just for toy use. Why not? You're writing to your coworkers and your future self. Then once you're done, you can right-click it and then click on locking the shape. Check the AnyLogic help about locking shapes. It's really useful because now it just sits in the background and you can drag on stuff on top of it, like functions, like variables. You put it into the nice bucket and you're good to go. You can even resize or add other rectangles, for flowcharts, make it look nice. Why is this such a superpower? If I open an old model for myself and try to understand what the hell was going on, this is really useful. I just read this like a book. I open an agent type, first thing I see is I read the little line at the top, then I see the functions. I know there's nothing scattered somewhere. Many people put their functions everywhere. It has its benefits as well, that's fine, but I find it more useful to all have them in one place, ideally even sorted by letters, but that's details. So, habit, agent template, superpower. Another habit and another superpower is, of course, sleeping or working out. Not really sure what this guy is doing. I'm pretty good at one of those two habits, not really good at the other one. So in AnyLogic, I also preach another habit all the time, and that is you shouldn't instantiate your agents just like that by dragging them in. You should always have an agent population that is empty. And there are lots of reasons for it. Again, other workshop. But there is one other reason or one other habit this supports. And that is that each agent type that I create will always get an finit function or initialize function. And I call it on startup of that agent type. And I do not call anything else here. This is the habit. The finit function is the function that is responsible for initializing the agent. So very often, another habit, it also calls an sanity check function, and the sanity check function itself then does some sanity checking on things like parameters. Are they within the range? Do they qualify for what I would expect and be happy with as a person? So having this habit in there, finit, sanity check, you can have other functions as well that finit calls. For example, instantiating more agents embedded in this agent, that's all totally fine, but you take control, and taking control is a really, really good habit. And having the sanity check for each parameter is a really, really good habit. Right, we're jumping through here, we're flying through. You'll probably, hopefully, rewatch this on half speed. Let's do a little bonus here. What do you think is more powerful than Bitcoin, Metaverse, or LLMs for a simulation model? More impact, more usability, more value. It's actually more sharp than any other tool in the shed. Well, it's this. It's another habit, whenever I drag anything in, the first thing I do is I go to a little other tool, a node tool, and paste some signature in there. So I drag something in, I go to a different tool and paste in something. So have that other tool ready. So let me share my screen. This is, let me share my display, and we'll do it live. Whenever I do some AnyLogic work, it's big. I work in AnyLogic, and then I Alt-Tab to some note-taking tool. And I have some signature stuff ready. These are Javadoc handles that just allow you to sign your work and make you remember when it was done. But also sometimes I have other things ready here. Little code snippets that I use all the time. So again, this is very, very useful. Little bonus tip. Have that ready and sign your work all the time. Please do that. Alrighty, now let's have a look at some more advanced stuff. So we're now leaving behind the absolute beginners and we're looking into some more advanced stuff, some more advanced tools. Let's sharpen up and let me go over here so you can actually see me. So let's start with something that I call a model template. But before we go there, a little story time. I went to a chocolate manufacturing workshop with my daughter. We wanted to learn how to make chocolate. It was really cute. And as part of that, there was this one wall where they had a little model of the actual machinery, of the actual factory, where the kids could basically play around with, and they actually got a little piece of chocolate at the end, which was pretty cool. Now, this is basically a simple model, right? And if you are the CEO of the company, at some point you might say, well, can we use this simple model and figure out some more stuff about Warmare, bottom left corner? Maybe let's refine that part of the model. Cool, let's do that. Let's use the base model and refine that bit and get some results out. And then 6 months later, the guy might say, well, we also need to update the mixing process. We have some questions about mixing on the right-hand side. So you use that base model again and refine the mixing side of things. What this actually is you're using what you could call a template model. So what you can do is to basically create little model templates that you reuse for certain aspects of your work. So let's have a look at, I'm going to share the screen, at one of those models. This comes from, there we go. This comes from one of my online courses, The Art of AnyLogic, where I teach people how to build models elegantly. And this is a manufacturing toy model. Make it bigger. You see everything. There we go. I need to remember that. So, little model template for manufacturing. Now, the real elegance and importance of toy models, template models, is the architecture. You basically pre-design a model for a certain industry, application area. So you have a manufacturing model, you could have a supply chain template model. You could have a model without any logic, just with your branding, for example, or some experiments, or just the data loading sites, or the data writing sites, or the KPI sites, or any mix of that. Now, this model is a manufacturing model, and the architecture is really useful. And you can always use this as a starting point. This is why I share that in the course. So on main, we don't really have any logic. Again, sorry. We just have some KPIs. And I use very good habits. I use an finit, which itself just does some sanity checks and then calls one function to create a factory. So I'm instantiating a number of factories. And the factory agent itself, this is the actual model. So with this little architecture, I could easily model several factories at the same time if I wanted to, or just one, which would be the standard case. So you kind of opening up the solution space or the flexibility. And then the factory itself, the model, again, very good practice, finit, sanity check. You don't have to have something in the sanity check, but it's good to have it there. And then I create the machines with a number of machines, just 5 in this case. I instantiate those machines. And here I do have some logic where we have product agents just arriving with some random weight. Everything is visible. Everything is explicit. And the machine agent itself then has a little machining flow, which is the most simple machining flow you can think of. Then they randomly decide to visit another random machine or be done with it and visit the factory exit and just be stored. Now, again, the details here are irrelevant. Go check out that course. What I do want to show is if you have a template model, it is very, very a powerful start, saves you a lot of time upfront. Now, let's have some real talk, though. I don't use those. I have tried several times in my career, and I always find myself being too constricted by them. And that, I think, is down to the fact that when you are more and more advanced and more experienced, building these is not a bottleneck. You can do this in an hour or less. And each client has their own little needs and their own, that informs the architecture upfront quite early. So very often I find myself not using them, just starting from scratch and dragging in a couple of blocks from other models that I know that I will need. So it's something to contemplate, but I'm not saying you must use those. What you must use is utils. So let's utilize the utility of your utils. Let's actually make some functions that you need again and again and unify them so you can easily use them again and again. Let's look into this. But before we go there, let me introduce you to Gary Dahl. Now, this guy and this story blew my mind. I literally thought this can't be real. This must be some LLM hallucination across the web where different AI agents have written from each other and copied the story, but it is actually true. This guy in the 1970s invented the pet rock because pets were expensive and a lot of hassle. So this guy convinced people might be good to have a pet, have a rock as a pet. Wouldn't that be cool? He made millions. He sold millions, of course, in the United States. So it's such a weird story. So there's lots and lots of useless inventions out there. Although I do like the baguette one here, pretty cool. We don't want to do useless utilities. We want to really build some sharp swords and a really cool set of tools for you. So what we can do is to actually create our own utils. Let me share my screen again. Let's go over to AnyLogic, close this one, and head over to this model. Now, this is a simple model, might have some logic, but why don't I create one agent type utils or utilities? Doesn't matter. Look how I'm using my habit here. And this agent type is a little special. Oh, not. I need to make it bigger. This agent type is a little special because I don't want to instantiate this agent ever. It should just live there as an agent type, or what you would call an abstract Java class. So I don't want to have a utils agent at my runtime, but I want to use this guy to hold functionality statically, as you would call it in object-oriented programming, that I can access anytime. So what do I mean by that? Well, if I have my model and I do some stuff, all I want to do is I want to say utils dot, so I just call the agent type itself, not some specific agent here, right? This is not population dot get the first agent dot. This is just calling utils. And then some functions that are defined in utils, like a sanity check function. Now, the first trick here is to make sure that this agent is never instantiated. You can do this by writing abstract into the import section. What this does in the background in the Java class itself is this actually turns it into an abstract public class utils. So if you're into object-oriented programming, you know this will not be instantiated ever. You'll get an error message. And now you can create little functions like a sanity check function that does stuff for you again and again. So this sanity check function will check if a given value is between a given min value and max value. And if not, it will throw what's called an illegal argument exception. So if I call this with this button, utils.sanityCheck, and the value is outside of that range, you'll get a nice, I'm sorry, this is the wrong one. This is the one we want. You'll get a nice error message. And it's again up to you to make this really informative, this error message. Now, the one trick that you need to do with this kind of setup is that not only the utils agent should be abstract, it doesn't have to be, but those functions have to be public and static. And if you don't see the static tick box, by default it's hidden. You need to go to Tools, Preferences, Development, and then tick the Library Developer mode. This will set up or allow you to make functions static. So that means it can be accessed anywhere, anytime. Utils.sanityCheck. You can do other things like converting units. So this utils agent can be used not only for sanity checking, also for other things. So, for example, I'm defining a public enumeration. This is nothing else or very similar to an option list, essentially a list of units, voltage units that should be existing in the model. I call it voltage unit. And I can create a public static function that allows you to convert a given value in volts into a different voltage unit. So get volt S will convert that value into whatever other voltage unit I want. And I can also make sure that I don't accidentally call it with some weird unit. So if I call this converting utils.getVoltS and I call it to convert 100 volts into millivolts, it will baseline that to me. So we now have like a global conversion tool that is accessible anywhere, anytime. Now, what I do suggest is, well, you have two options now. Either you just copy and paste this utils agent into each new model that you create, or you just have one dedicated model like this one that manages the utils agent. And then if you create a new model that should use that, you know, that's your new shiny model for your new shiny client. All you have to do is in the model properties, tell this model, you should now depend on a different model as well. In this case, this 0302 utils agent model, because this one holds the utils agent. And now in my new model, without it having any utils agent itself, I can call code complete. There is the utils. Sorry for my typing. And then I have access to the sanity check functions or that unit conversion function as well. This is typically the better option. You have one model where you manage the util agent and update it and add new functionality, and then make your other models depend on it. The disadvantage here is that you need to have that utils model open while you work on your other model, which is fine for medium-scale developers, but we'll see later where all this is heading. Alrighty. Another thing is handling data, obviously. I don't want to scare you, but this will be a little bit scary. AnyLogic has the built-in AnyLogic database, which is great. It has data loading functions, which are great. But we all still always struggle with messy data, right? So if you have kids in the room, please take them out, blindfold your eyes. I really don't want to scare you too much, but it's so shocking. It's like, oh my God. So dirty data. This is what we have to deal with all the time, right? And then it's an Excel, which makes it even worse because now is the absolute nightmare of all nightmares, which is Excel just seeing everything as dates and you handling dates. So maybe you need to create your own data handler agent, similar to the utils agent, that handles this kind of stuff for you. Typically, what I teach people is you need to have kind of a strategy. You have messy, dirty data, really, really bad dog, very aggressive, scary. Your model should never touch the messy data. Then you have the AnyLogic database, you put the external data in there. It's kind of a bit cleaner. You already do there's always some checking being done. So you put the nasty dog on the leash. And then you have your puppy model, which should never really touch real data at all, actually. Instead, what you should have between those is like a Chinese wall of OJOs, plain old Java objects. Again, I'll not go into the details of that because that's a different talk. But what I want to show you is how we can use a data handler object in the middle to make sure that this messy data is actually cleaned. So first of all, we'll make it big again. Then let's close this one. Don't need you anymore. Let's have a look at this one. So The usual data setup is that I have some external data and it is scary and messy. Look at this mess. Oh, what a pain. So what I teach people is you should have a Java class, a Pojo class, that duplicates this data structure. So you have 3 fields, the ID field, the name, and the age, mimicking the 3 columns here. And a constructor that takes those 3 and gives you a Pojo person. Then when you want to create actual people agents, you loop through your database for each row, you get the 3 fields. And before you create actual people agents, i.e. start the logic of your model, you create little Pojos first and give them those names or those fields. And then your people agent or your person agent type only has one parameter, a data parameter of type Pojo, because now you have access to all those fields. If your data structure changes, you don't need to change a lot in your model in the Pojo. It's all a lot more elegant. So, but that's a different topic. The problem now is, if I run this model, I need to remember to run the right model, and I create my agents, I get a nasty error message, integer, int value, null pointer exception, not really helpful, what the hell is going on? This is because the data is still messy, and we can't create those agents yet. So why don't we have a data handler object in the middle, again, abstract, where I have some public static functions, public static, and for example, use one to check the age field. So I give it a row of data. I also say, should this throw an error or not? If there is something wrong, I pull the age from this row of data with a try-catch statement. And if it doesn't work, so it does catch this null pointer exception, I either throw an error if I want to, or I actually replace it with some default data. So you can define that default data and have clean data. So let's have a look at how that works. If I loop through my data now, instead of just creating the Pojo directly, I get my age from the data handler, get check an age, I give it the row, I say don't throw an error, just replace it with the default data, then create the Pojo with absolutely clean data, and then create the people with absolutely clean data. If I do that, click that button, I will create all 6 agents. We had 5 already previously from the 40 setup, and no error messages. So now my people will have been created, but with default data. And I do have little warnings here telling me about that. So data handler, also a really, really good application to make sure that the messy data gets clean. All right, now let's go completely haywire. We'll go completely crazy now. And everything so far that I've shown basically points into one direction, and it is towards the library. You will want to actually unify all this stuff in your own library. That's typically the most elegant way. Now, AnyLogic has already a webinar about this, so go watch it. It's really, really useful how to create a library, the advantages and all that kind of stuff. Will not go into this, but what I do want to show you is my library. So just a couple of months ago, I decided, well, it's time for me to also create my own library and reuse stuff and not copy and paste stuff. So let's close all this. I call it AnyDev. Now, let's say we have a model that needs to do sanity checking. I know we all want to do sanity checking all the time. It's so important. You don't want to write this code all the time. Why don't we help ourselves with giving us a little bit of help in sanity checking? So with my library, what I can do is I can just type sanity check, and then it guides me through the sanity check with code complete. So I don't need to remember what I need to write. I can just say sanity check that a certain number, and I then give it the number. Then it only gives me one option. It needs to name the field. So this is to remember where this was, button on name, whatever. And now it lets me check, is this number named blah, blah, blah between something, or is it larger than something, or not null, or is it smaller than something? So I can do all those things. Check if it's larger than 11. And last but not least, it wants to know what should I do if that actually is not the case. Should I then break or log it or replace it with something else? So this kind of code reads really nicely. You can read this like a book, right? So that's very elegant. And if you execute this, this will throw then a pop-up or an error message. Now, how did I do this? In this library, I've got this one Java class sanity check. So this is what we access. And in this, I only have two public static functions, that number and that string. And what they return is, in this case, an SC number name. So it goes into the SC number class. And in here, it has the SC number named interface. It's a public interface, which then returns an SC number condition, which is this interface, which allows you to then call 6 other methods. So what this is we're using a builder pattern in Java. This is what LLMs really, really shine at. And with the builder pattern, we chain together methods. So this is called literally method chaining. And we force the user to go through a number of methods. Sometimes we allow them to use different alternative methods, sometimes only one method, but we let them go through, or we guide them through what they can code. And these blocks are just Java classes in my library. But if you have, if you make those Java classes static, public static classes, you can access them as a library as well. So let me share my screen one more time. And make it big. So the sanity check class is just a public class. I have a utils class as well, not an agent. My utils are all just in a Java class with public static functions doing some stuff like this get state trace function, which is quite useful to just print where something was going on. And if I compile this library, I have access to it from any model, just like with usual libraries. The only difference is that there is no block that you drag in. You just need to remember that you have a utils class, sanity check class, that kind of stuff, and document it well. All right, now let's have a look at where we are. You also want to do testing. We already talked about unit testing. Let me skip the story and jump right into the model. Let's look at a little kind of tweak for unit testing. You don't need JUnit because it has a lot of overhead. You might want it, but you don't have to use it. What you can do instead is create your own little unit test class. My unit test class is very, very simple. What I can do in my model is I have little functions that I give a custom modifier, in this case, to add to unit test. This will flag this function to be included in a little custom unit test. I have these assert unit test.assert functions, which I just define in the unit test class. This is really not rocket science. They're very, very simple for assert equals, assert true. You know, there's nothing fancy there. The only fancy thing is that I have one little function, the run test function for a given class. And you can give it an agent type or a Java class. And through reflection, what this is doing is it gets all methods that have the annotation to unit test present. So any method that has this annotation add to unit test will be executed and will run those assert tests. Now this add to unit test is also just defined in my library. So it is itself just a Java class where I specify that it's a method to be called at runtime. And in my model or in a separate experiment, I can just say, hey, my dear unit test class, please run all tests in the my agent type. And it will go into the my agent type and it will find all functions and Java methods that have this flag. So it works very, very similar to JUnit, but it's 100% yours. And you can adjust it and improve it and do stuff with it any way you like. We have 1 more minute, so let me show you the little bonus one for our library developers. You have a big fancy library, you have good habits, so it's nicely documented. you all know that if you, well, the advanced people that are doing libraries know that if you export the library, you get a little doc folder with it. And in that doc folder is the actual Java doc. If you open the index.html, you get the entire Java doc for this for your library. In this case, it's for my little AnyDev library with all the Java doc code that I put in there. It's all there, all the functions, the signatures, whatever. But this is hosted, like this is local, so it's not even hosted. Wouldn't it be cool if this would actually be on a website like this one? So this is an actual public website that you can go to, have a little landing page, little how-to install page, where I describe how it should be installed, a link to my website. By the way, go visit it and reach out to me. Oh, that's the dashboard. And there you can actually write to me or have a little meeting with me. And at the third button, you actually go to the JavaDoc API reference. Same thing, but now it's hosted online on GitHub publicly. The way to do that quite easily is you just create a public repository. In that repository, you don't even need to upload the library itself if that's sensitive. The only thing you do create is a little docs folder. In there, you have an index.html that you can just use an LLM to write, for example, to create this landing page here, and then a subfolder, JavaDoc or something else. And in here, this is where you simply post, copy and paste all the stuff that the exported library has created. Just put it there, tell the LLM to link to that subfolder, and now you have a publicly available page. The only last step in the repository is you go to settings, then pages, and tell it to deploy from a branch. Don't use the GitHub Actions one. Deploy from a branch, tell it to deploy from the main branch, the docs subfolder, and then it will create this website. And whenever you have a new version of your library, all you do is copy and paste the latest docs into this repository, and you have a nicely updated, publicly available, shareable website for everybody. Now I didn't make it large, but there we go. Good. Now, tour de force, run it again at half speed. If you have any questions, if there was something that you couldn't see or something, reach out to me over my website. If there are questions and we have time, I can also answer them. Otherwise, I'll see you in backstage. Enjoy the rest of the conference. Thanks for having me. I had a lot of fun.